In this video, we're going to prove the AM-GM inequality. This is the arithmetic mean, the geometric mean inequality. It says that for A1, A2, etc. until AN, which we assume that all are positive, we have the sum of I going from 1 to n over n, and this is the arithmetic mean is bigger than the product, the nth root of the product of A1, A2, AN. Okay, which I write the nth root here, which I write as n by I going from 1 to n of AI. Okay, so this is a compact notation for the product. Now, to prove this result, we're going to use the following. So we can prove that the natural log of x is less than or equal to x minus 1. There are many ways to prove this result, but the most important thing is how can we use this one to prove this. Here, to convince you that this is true, we can use graphing even if it's not a proof. So here, the natural log of x is less than x minus 1. So the graph of x minus 1 is on top of the graph of x, except when x is 1, where we have equality. Okay, so the key here is we're gonna use this one here to prove this result. Okay, so that means what are the x's that we can choose to make this one work. Okay, one good way is that if we let x1 is be A1 over A, where A is this one here. Okay, A is the arithmetic mean. Okay, so that means x1 is A1 over A. Okay, so now if we do the same thing, x2 is A2 over A, and xn is AN over A. Okay, now if we apply this result here to x1, x2, and xn, what do we get? We will get the natural log of A1 over A is less than A1 over A minus 1. The natural log of A2 over A is A2 over A minus 1, etc. until the last one, which is AN over A is less than AN over A minus 1. Okay, now we're gonna sum all these numbers. If we sum them up, we're gonna get the natural log of A1 over A plus the natural log of A2 over A, etc. until the last one, AN over A. On the right side, we're gonna get A1 plus A2 plus AN, all of them over A. We're gonna get A1 plus A2 plus AN over A minus 1, 1, 1. How many ones we have? We have n. Here, this sum on the left, I can rewrite it using the properties of the log as the natural log of the sum. Okay, this sum can become a product. So it's going to be A1 times A2 times AN over A to the power n. Okay, less or equal than. Here I can rewrite this one as the sum of AI over A minus n. And remembering that A is this sum here, so that means this sum here, A going from 1 to n, is just an A. This is just an A over A minus n. Let me write it here to make it clear here. So this is just an A. So NA over A minus n, it's n minus n, which is 0. So this one here is just 0. Okay, and therefore I have the natural log of the product. Let me use the compact notation here. Okay, an over a to the power n is less than 0. Okay, now if I can use the exponential, I can write this one as the product over a to the power n is less the exponential of 0, which is 1. Okay, and therefore I have the product of I going from 1 to n is less or equal than a to the power n. Okay, now if I take the nth root of both sides, I will get the nth root of the product of I going from 1 to n is less than a. And what's a? Okay, a is this one here. I defined a as this sum here. So therefore I have the equality that I need. So I have a is bigger than the nth root of the product of I going from 1 to n, and this means that the sum of I going from 1 to n over n is bigger than the product, the nth root of the product of the AIs. Okay, and this is what you need to prove. So this is the one that I want to prove. Okay, this means that I proved the AM GM inequality. Okay, so here using this one and choosing carefully this element with A being the arithmetic mean, I can arrive at this result. Okay, the only thing that we didn't prove is this one here, but to prove this one here, use or see my video on the mean value theorem for this one here. I have proved it. Or you can convince yourself that it's this one here. Or you can define a new function that you call g of t. It's gonna be x minus 1 minus the natural log of x. And you can study this one here on 0 plus infinity and see what's the maximum, what's the minimum. And from there you can get this result here. Okay, I think that's all we need here. If you see any errors or mistakes, please let me know. Thank you very much.